In today's world of barcode tracking and highly automated processes, it's becoming increasingly critical to add a barcode quality control step into the manufacturing system to help achieve the benefits of automatic data capture and ensure readability of barcodes throughout the supply chain. Worldwide, more than 5 billion GS1 barcodes are scanned every day. This helps retailers, manufacturers and other supply chain trading partners to run several critical business applications pertaining to demand forecasting, automated replenishment, track and trace, recalls, automated warehouse management and item master alignment. Automated data capture has become critical to a company's success, and the results of scanning failure can have a serious impact. Imagine what happens when a GS1 barcode doesn't scan the way it's expected to. It breaks down information flow and requires manual intervention at great cost, inaccuracy and delay. Here's what your members lose if their GS1 barcode doesn't scan. It brings data inaccuracy in the supply chain, involving wastage of time and money, and all that's gained is an angry customer and a general attitude of these barcode things don't work. Barcode quality control procedures, including verification, ensures that GS1 barcodes are correctly created and printed so that they're read by any scanner anywhere. GS1 verification ensures compliance with symbol quality industry standards and directives. It maximises efficiency of the manufacturing process. It provides real-time quality control as companies can verify the output from their printer or code marking equipment. It minimises returned goods due to bad labels, and it increases customer satisfaction. Firstly, what is a verifier? It's much more than an ordinary scanner, but in simple terms you can think of it as a very smart scanner. It not only scans a barcode, but it analyses many aspects of its dimensions and its reflective properties and reports against an ISO standard that defines how to grade various aspects of the barcode. We'll go into those details later. There's a lot of equipment called verification equipment on the market to check various aspects of number correctness or barcode quality. Many are not true verifiers for GS1 purposes. The type of analysis required by GS1 specifications is called scan reflectance profile analysis. It's defined in ISO standard 15416. Ordinary scanners are not all the same. If a barcode is not fully correct, some scanners may scan it and others may not. It's entirely possible that a barcode that you scan successfully at your premises doesn't scan at the retailer's or buyer's end. This happens because there are hundreds of different kinds of scanners which yield different, even conflicting results. Verification, on the other hand, involves consistent and repeatable measurements of barcode parameters as per ISO and GS1 specifications. Then these measurements are analysed in relation to the expected scanning performance of the barcode under a range of conditions, and a verification report is generated on the basis of this analysis. Much equipment that is often regarded as verification equipment is not actually checking to the correct ISO and GS1 standards. This one, for example, will check for the impact of ink spread, but will not check any of the ISO parameters that relate to reflectance measurements. The ISO standard tells us what size scanner must be used to test each type of barcode. Remember, we're talking about scanners that are attached to verifiers, not ordinary scanners. When we say size, we're referring to the size of the aperture in the scanner. The aperture is the opening in the scanner that releases the light and captures what's reflected back. Some verifiers have separate scanners or input devices that the operator changes as required. Others have fixed scanning devices that automatically select the correct aperture for the barcode that they're testing. Aperture sizes are expressed in mils. This is an imperial measurement, not metric. 1 mil is 1/1000th of an inch. The three aperture sizes used for testing GS1 linear barcodes are 6 mil, 10 mil and 20 mil. Be careful not to confuse mils with millimetres. Ideally, the aperture in the scanner on the Verifier should be 80% as wide as the narrowest bar in the barcode. We use a 6mm aperture to test EAN UPC barcodes and GS1 data bar. For all GS1 128, regardless of size, and for ITF14 printed below 62.5%, we use a 10mm aperture. And for ITF14 printed at or above 62.5%, we use the 20mm aperture. The ISO standard defines a set of grades that are assigned to various aspects of the barcode being tested. There are 4 grades and fail. The grades can also be expressed as numbers. This is the better way because it allows more precise measurements when we include decimal fractions. So we can know the grade our test achieves, or that we're seeking to achieve, and the size of the aperture used. For example, to express a C grade, we would write 1.5 because C is 2, and where we have decimal fractions, 2 effectively starts at 1.5. And let's suppose that we did this test with a 6mm scanner. The last thing the ISO standard specifies is the wavelength of the light source in the scanner, and this must always be in the range of 660 to 680 nanometers. This is a full and correct way to say C grade with a 6mm scanner. Using this method, we can express the grades that GS1 has defined as passing grades for each of our linear symbologies. We use a 6mm aperture to test EAN UPC barcodes and GS1 data bar, and we require a C grade. For GS1 128 and ITF14 printed below 62.5%, we use the 10mm aperture and still require a C. And for ITF14 printed at or above 62.5%, we use the 20mm aperture. This time though, we only require a D. But beware, the Verifier will tell you whether you have a good barcode, but not whether you have a correct barcode. You must make additional observations to confirm that the barcode is fully compliant with the GS1 standards. You must check these things. Is the number the one that was assigned to that product? Is the number the one that was encoded in the barcode? Is the symbology the correct one for the job? This is an ITF14 symbol, so it wouldn't be suitable for point of sale, but is used in distribution. Is the symbology the correct size? Remember that the size requirements for EAN13, for example, vary depending on whether it's intended for use only in retail or in retail and distribution. Are the light margins sufficient? Is it high enough? Is it in a suitable location for scanning? Is there anything about the location or the packaging that will interfere with scanning? You should always try to test authentic samples, ready for market or as near as possible to that state. So we see that the complete GS1 verification test has 3 parts. A check to ensure that the GTIN is correct and is in the barcode. The required ISO grade is met or exceeded. And all relevant GS1 specifications are met. So much for the theory. Now let's see how you will actually operate the Verifier. The Verifier must be calibrated before use using the appropriate calibration card. These are available from the Verifier suppliers. They must be kept clean and stored flat, protected from dampness, heat and light. Wherever possible, a barcode sample should be tested with the product in its final form ready for market. The barcode on an empty packet may be fine, but when the packet is filled, the barcode may be quite different. If you must test an empty example of a package whose product may show through, try to find a colour similar to that of the product to place behind it. The sample to be tested is placed flat if possible. Some samples may not be capable of being laid flat. In these cases, you must do whatever it takes to enable the test to be carried out. This may mean scanning the barcode as it is, which may require a different scanner, or holding the item in a particular way. In extreme cases, you may have to cut the barcode out to test it, but this is a last resort because the barcode is no longer as it appears in the marketplace. The correct ISO verification test is based on 10 scans taken over the full height of the barcode, but not including the top 10% and bottom 10% of the symbol. Take your 10 scans. On each scan, the verifier will draw itself a graph or profile of the reflected light from the barcode. This is the scan reflectance profile. The high points on the graph are the background spaces reflecting a lot of light. The low points on the graph are the bars reflecting less light. The verifier finds the brightest spots on the profile and the darkest spots. These are known as Rmax, the point of maximum reflectance, and Rmin, the point of minimum reflectance. It draws a line halfway between them. This line is the global threshold, and all of the linear measurements are taken along this line. The quiet zones are assessed for width. The contrast is measured at each bar edge and compared to the overall differences between Rmax and Rmin. The edge with the weakest contrast is identified. In this case, it's the fourth edge from the left. The verifier measures various attributes or parameters of the barcode by analysing the profile. Symbol contrast, a simple comparison between the brightest and darkest points. Minimum reflectance, Rmin, a check that the bars are dark enough relative to the spaces. Bars must be half the reflectance of the background or less. Minimum edge contrast, the contrast between each dark edge and the light edge touching it. If this is too low, then that edge may not be discernible to a scanner. Modulation, the contrast along each edge is expressed by a ratio of the symbol contrast, and the space that the verifier finds hardest to see is identified. Think of modulation in music, the rate at which tones rise and fall. If they do so too quickly, the music becomes discordant. In the same way, the variations in reflectance across the scan profile should occur smoothly, but a sudden space that is hard to see will interfere with the smooth rise and fall and will be a reflective bum note. Defects, dark spots on what should be light areas or vice versa. If they're too big, they'll create a spike or a dip in the profile that will cross the global threshold and appear to be a bar or a space that shouldn't be there. Decode, the verifier asks itself, am I sure that ordinary scanners in the world at large will be able to scan this? There is no grading for this. The answer is either yes, A, or no, F. Decode takes into account character encoding, check digits and light margins. GS1 128 has two check digits, the one in the number that you can see and another the symbol check digit that is buried in the barcode and invisible to human observers. Decodability, an assessment of how easily decodable the barcode is based on a comparison between each individual character in the barcode and a perfect example of the same character in which all of the widths are exactly correct relative to each other. Here's an example of a defect caused by a thin white line down the centre of a printed bar. You can see that if it were high enough, it would touch the global threshold, shown at the blue line, and create the impression of a thin background space down the centre of the bar. On each scan, the verifier will report grades for each of the parameters and will report the poorest of all the grades it finds. The result is called the scan grade, the grade achieved in a single scan. The verifier averages the results of the 10 individual scans. This average result is called the symbol grade. Remember, this is very important. Each individual scan produces a scan grade. Passing or failing the test doesn't depend on these alone. Some individual scan grades may even be fails. Passing or failing depends on the ISO grade of the average of the scan grades, the symbol grade. So our barcode has achieved an ISO grade of 2.8. We know that it was an EAN13, so we will have tested it with a 6mm scanner, or the verifier will have automatically selected 6mm if it was a type that chooses its own aperture. And the light source of most verifiers is 660 nanometers, so this will be stated in our result also. So our symbol grade is 2.806660. We know that 3 is B grade, and the B grade covers numbers 2.5 to 3.4, so our barcode achieved a grade of B. Because the grade is within the range 2.5 to 3.4, when we tested it with a 6mm scanner, on a verifier with a 660 nanometer light source. But what if it had failed? Now we must understand why. Did our barcode fail for simple contrast? This is simple. Is the difference between light and dark enough to provide a clear view for the scanner? Minimum reflectance, RMIN, is a check that the bars are dark enough relative to the spaces. Bars must be half the reflectance of the background or less. It's really the same thing as contrast, but differently expressed. A failure for contrast or RMIN is simply corrected by increasing the difference between light and dark. Sometimes a shiny label may have contrast problems. See if it can be made less shiny. Next, the verifier assesses the minimum edge contrast by examining the contrast between each dark edge and the light edge touching it. If this is too low, then that edge may not be discernible to a scanner. The edge with the weakest contrast is identified. The contrast along this edge will be reported in the parameters that will make up the scan grade. Good contrast and clean, clear edges should make for a good result. If not, contrast and print quality need improving. Excessive bar gain, translucent and reflective subtrays also give poor edge contrast. Modulation is assessed. Remember the comparison with music? The smoothness of the changes between notes. But we're thinking of the smoothness of the change in reflective peaks. Scanners will always tend to see bars and spaces as being narrower than they really are, and the lowest modulation grade in any scan will always relate to the narrow space that's hardest to see. A poor modulation result may be due to bars being too wide relative to spaces, so the bar width reduction could be increased. Generally, poor modulation is linked to poor edge contrast. Here too, good contrast and clean, clear edges should make for a good result. If not, contrast and print quality need improving. Defects are dark spots on what should be light areas or vice versa. If they're too big, they'll create a spike or a dip in the profile that will cross the global threshold and appear to be a bar or a space that shouldn't be there. See the little spike sticking up from the baseline in the centre? That's a defect, a light feature in what should be a wide dark bar. You can see that if it were to go high enough to touch the global threshold, it would look like a narrow space to the verifier. Yet there is no space there, or shouldn't be. To avoid defects, ink should be dark and even on the bars, and the background should be clean and evenly coloured in white or some other colour that is lighter than the bars. A warning. Some materials that look clean to the human eye may have variations in texture that look mottled to a scanner. To assess the decode parameter, the verifier asks itself, am I sure that ordinary scanners in the world at large will be able to scan this? There is no grading for this. The answer is either yes, reported as an A, or no, reported as an F. Decode takes into account character encoding, check digits, and light margins. If you get an F here, then the barcode is in trouble. You need to analyse the report to see which parameter or parameters are failing and advise the company how to correct any problems you find. Decodability sounds the same, but is importantly different. This time the verifier asks itself, how easily decodable is this barcode? It examines each character in the barcode to see how closely it complies with the specifications concerning the relative widths of the bars and spaces. For example, a 4 in EAN 13 is one dark bar and one background space, each the same width, followed by a dark bar 3 times as wide and then a background space twice as wide. The verifier compares each 4 character in the barcode being assessed. We see that in this case there's an irregular width error across the symbol, so it won't be as easily decodable as it would have been if all the widths were correct. It will achieve a lower decodability grade. Decodability failures are due to irregular bar width errors. These must be corrected. Once all information on the tested symbol has been collected from the local database, verifier and any visual checks, the GS1 barcode verification report should be fully populated. This GS1 barcode verification template was developed in cooperation with retailers, manufacturers, logistic providers and equipment providers to ensure a common reporting approach on a global level. This helps ensure consistency regardless of where and by whom the symbols are tested, thus removing the costly and inefficient requirements for multiple testing of identical symbols and reducing the cost of compliant equipment. GS1 has developed this verification template on the basis of ISO standard 15416 barcode print quality test specifications for linear symbols. This not only allows for assessing the quality of printed barcode symbols, but also checks against other key aspects of GS1 standards and location recommendations. All of the ISO information you will need is on the proprietary report. The exact location of each piece of data will depend on the format of each Verifier's report. You simply transfer the relevant data from the original Verifier report to the GS1 verification report, inserting the findings of your GS1 related inspection. In the comment space on the global template, make concise and simple comments to advise the member how to correct any faults that you found during the test. No doubt your member organisation produces various reference documents for your members. Please review all of your material to ensure that it's accurate, up-to-date and simple enough to be useful. Remember that Global Office also produces a range of useful literature and is eager to help you to ensure compliance with our specifications and to promote numbering accuracy and barcode quality worldwide.